go to the top of Mount Everest, you won't be able to breathe, but look at you can boil your noodles at 70 degrees C. Won't be able to breathe. And then with high pressures, boiling point's going to go up. Boiling point's going to go up. And one thing I also want to mention to you with the weather. Look at the weather. You got the H's on the weather map, the L's on the weather map, don't you? So when the H high pressure system, meaning barometric pressure might go to like 766, 770. It's a nice day. In a low pressure system, it might drop to like 750 or so. And what wind is just the equalization of those two pressures between a high and a low pressure system. So if you get a really windy day, you know we're probably going to get a storm coming at us in another couple days later, which I think wind's supposed to pick up. We're supposed to get a storm, I guess, over the weekend, I think, right? Our first nor'easter, but it's going to be all rain, thank goodness. But that's where wind comes from. It's just high pressure, low pressure equalizing. That's where it comes from. Also, one thing I'm going to mention to you is deep sea diving, but actually deep sea exploring with a submarine. The submarine, the Titanic was 2.4 miles down, and you can imagine when you're down that deep how strong that pressure is. That water is just smushing. So they call it an implosion. And if there's a problem with that submarine, there's a problem with the hull of that submarine. And what it'll do is it'll crush in like a soda can, like that, because the pressure is so outrageously high. That's why it's so dangerous. You guys ever watch submarine movies? Yeah. And they lose power and they're sinking and they're sinking and they're sinking. And they lose power and they'll hear the hull cracking. And what'll happen, that's why it's so dangerous, as they discovered the wreck of the Titanic, 24 miles down. Can you imagine just how dangerous that is? I'm sure that wall of the submarine is probably like that thick. I'm sure it's outrageously thick. All right, going to the next page. I'm just rambling on today, huh, Flash? You like rambling on? You like watching videos? Today's video day. Want me to pull some more up?
Yeah.
No. Go to the next page. Some more videos. Properties of gases. See how pressure is measured in atmosphere, millimeter mercury, torr, pounds per square inch, kilopascals. Volume takes the gas takes the shape and volume of the container. Tidal volume. This is what you guys are doing now. Normal, quiet breathing, nice quiet breathing is called tidal volume. Air moved in or out per breath. And normally it's 10 cc's per kilogram of body weight. All right, so got your calculator? All right, get your calculator out. Now, put your body weight in pounds. How many pounds you weigh? So put your body weight in pounds. Divide by 2.2. So your body weight divided by 2.2 equals, then multiply by 10. Times 10 equals, and some of you guys might have a tidal volume anywhere from maybe 500 up to 900 or something. That's just the amount of air you're breathing in. Nice quiet breathing as you're just sitting there listening to me ramble on. That's called tidal volume. Now, if you would on your practice quiz, would you please do number 4 on your practice quiz, if you would, please? So flip to the back, and if you would, please do number 4. The tidal volume is 10 cc's per kilogram of body weight. Bless you. What would it be for a patient weighing 220 pounds? So here's what you do, guys. Take that 220, go 220, divided by 2.2 equals, then multiply by 10. That's all you do. So 220 divided by 2.2 equals, then multiply by 10. That's all you do. What did you guys get for an answer on that one? There you go. Very good. So it'll be 1,000. So someone's going to be hooked up with what's called life support, mechanical ventilator, breathe for the patient. That's with the number you would dial on the machine. Temperature. Now the temperature with these gas law calculations, we're going to use Kelvin. Can't use degrees safe. We're going to use Kelvin. Because at absolute 0, gas volume 0. So we got to use Kelvin. the amount of gas is going to be stated in moles, and that's like a small n for number of moles. Now here's our first gas law. Now for the first gas law, it's called Boyle's law. Gas volume varies inversely with, with pressure at a constant temperature and number of moles. Listen, you know what it is? It's like a tire pump. Look at a tire pump. You got your cylinder, you got your little piston, and you got your handle. Say we have 2 liters, and you got your little pressure gauge right now. Right? Got a little pressure gauge. Maybe it's at 0. Now what happens? When you decrease the volume and you push this down, what happens to your pressure gauge? It goes up, doesn't it? So as you decrease the volume and increase the pressure. Very inversely means one goes up, the other goes down, vice versa. So here's what we're going to do. We're going to take a first initial set of numbers. First set, sometimes you might see an I and an F, initial and final. But we'll take initial set of numbers and a final set of numbers. We'll solve for the unknown like I did earlier with when we first started this. So here's what we do. These are actually pretty easy. Thinking what? I got to memorize all these stupid equations? No, I'll show you a little trick with that. Let's see. So there's your formula. First pressure, first volume equals the second pressure, second volume. Can you see that okay? Use your imagination. Here, let's add this to our collection of dried up markers. There you go. Thank you. Let's see how many we can get for the end of the semester. Try it over again. See if this one works. Nothing but the best for my students. V1, V1, V2, V2. All right, let's see what we got here. I have 100 mLs at 1 atmosphere. Here's our first numbers. All right. First pressure, 1 atm. Okay. First volume, 100 mLs. Okay, got that one. Equals, what is the new pressure? All right, so P2, that's got to be X. If the volume is decreased to 50. Second volume is 50 mLs. Now, you have to solve for X. That's why I did that, basic stuff earlier. So 50 mLs, they divide out, divide by both sides. Divide 50 mLs over on this side. And cross off your mLs, or don't cross off the numbers. And just solve for X. That's all you do with these. What'd you get? What'd you guys get on this one? Did you get 2 what? ATMs. Right, 2 ATMs, 2 atmospheres. Plug your numbers in, solve for X. That's all you guys do. There you go. Can you do this bottom one for me? This next one here. Come on. Plug your numbers in, solve for X. Let's see. We'll make this one fast. Let's see, guys. Volume 12 liters. Pressure 200 torque. So 200 times, let's see, 12 liters. Okay. What's the new volume? The pressure is 600 torque. So go 600. That's 604 times X. Times X. See, the thing is, guys, units will divide out. So we're going to divide by 604 on the side. And use measurement, so the 4 is going to divide out. What'd you guys get for an answer on that one? I got 4 liters. 4 liters? See how to do these? They're pretty easy to do. There you go. Right. Yes. No, just keep them as they are right there. Just leave them. Yep, just leave the units. Is that what your question was? Yep, just leave them. Which I'm going to show you a problem where Just the thing is Israel, you gotta make sure that they're the same units